Hello class, today we study chapter 11 about recursion. But what is it? When you study chapter 6 about iteration or loop, you study why, do, why, and for. At that time, you can run an action many times. And now when you go to recursion, you have the same problem. Firstly, a recursive function is one that solves its task by calling some or smaller pieces of data. For example, we have the function running sum. You want to get the sum from 1 to n. So we define the function running sum, and the terminal value when we pass 1, we return 1, and when we pass n, you return n plus running sum n minus 1. And that we call itself. So we can define the function, recursive function, running sum like this. Okay, we check if the argument 1, so we return 1, otherwise we return n plus running sum n minus 1. We call itself. So with this, we see now running sum 4. So we call running sum 3, and then running sum 2, running sum 1, and finally we return 1, 3, 4, and 10. Now we go to a high-level example for binary search, one of the famous applications for recursion. Over here we have a sorted list for values. For example, you have 10 values and they are sorted, they're integer and sorted. And you want to find out the value 23, and we have some values for the indexes start and end or low high. We need to find out the midpoint over here, 16. The midpoint, that means the index for the value 16 over here, and we compare and we see 33 is greater than 16, so we go to the upper half to find out the values you want. And over here with the upper half, so we check the value for start and end or low high. So we find out the midpoint or halfway point. We find our midpoint, that is index. Okay, we compare. Now 33 is less than 56, so we go to the first half or lower half. Of course, we have to change start and end. At the end, so we find out the value you want in the list. So that's 33. You can bring out each index. So now we have an example. For binary search, we have to find the exam for a particular student. So we have to look at the exam halfway through the file. And if it matches the name, so we done, and if it doesn't match, so then we go to the case phrase with two different cases. A, if the name is written down alphabetically, then we search the upper half of the stack. Otherwise, we search the lower half. So we have the shellcode for the function for exam with arguments to the name, start and end of the list. Firstly, we have to find out the halfway point and midpoint from the value start and end, and we check it if end is less than start, so we say no, exam not found, because normally end is greater than start, so when we face the case, so we say exam not found. Else, if otherwise, okay, we check. Now, student name is name of exam halfway point, so at that time we say exam found. But otherwise, else if student name is less than name of exam, so halfway point, so we have to set lower part, okay? So at that time, we call the function for exam with student name. Okay, start and halfway point minus 1. Else we call the function, but we have to find in upper half. Now we go to the other example for high-level example towers of Hanoi. And our task is we need to move on this from current post to another post. So over here now we have three posts, post 1, 2, and 3, and post 1, the start post. And post 3, that the end post, and post 2, that's a temporary or auxiliary post. So we have the rules when we play game. Okay, we can only move one disk at a time. A large disk can never be placed on top of a smaller disk. And we may use the post for temporary storage. You know, over here now you have the game, and you can go to the link over here to download the game, and you can play it at home. Okay, this is the link for the game, and you can download and you can play at home. And in class, so we have a small competition between you. Now, please look at the task closely, and we see we need to move top -1 disk to post 2, and then we move the last disk to post 3. Okay? And then we move -1 disk from post 2 to post 3. So we see now task 1 is really the same problem with fewer disks and different task ports. And we move -1 disk from post 2 to post 3. So when you go to the function extension to start post and post, okay, because we have 3 posts, so when you write the program extension to this, and task 3 is the same. We move -1 disk from post 2 to post 3. And this is a recursion region. And the terminal case is moving the small disk. Okay, we can move directly without using third post. And we should number this from 1 for smaller to n for the largest. And we have the shellcode for the function move this. We have to pass the argument this number, start post, end post, and mid post. And we check now if this number is greater than 1, so we need to move top -1 disk to mid post. So over here now, attention, we write over here the second, okay, and post is the mid post because you want to move top -1 disk to mid post. So that's the end post. And the end post becomes the mid post. Okay, and then we have to move the largest. Over here we have to move the largest to post 3, the end post. So over here we say now we bring out, okay, move this, okay, this number, the largest disk, okay, from start post to end post. And then we move -1 disk from mid post to end post. Okay, over here now we use start post as the mid post, a temporary post. Okay, and we moved -1 disk from mid post to end post. Okay, else we moved the smaller disk, okay, number 1, okay, from start post to end post. And now we go to the example for Fibonacci numbers. With the example, you have Fibonacci numbers. So that time we have the same problem when you use the function, recursion function. Over here we have Fn. When you want to compute the Fibonacci numbers, so you call itself for getting Fibonacci numbers -1 and -2. And you have the terminal values f1 is 1, f0 is 1.